All right, ladies and gentlemen, this is Unit 1, our second presentation of Unit number 1. And this is the big part of Unit 1, right? Everything that we are going to do outside of this set of notes is really to get you ready for this part, which is how to design a controlled experiment. All right, in 6th and 7th grade, you probably learned the scientific method. We're going to go a little bit further with that. I'm not going to specifically go over every detail of the scientific method just because you've learned it. My part is how can you design a controlled experiment, because this is kind of like the theme that you're going to be going through as the year progresses. All right, so let's get started on what does it mean to design a controlled experiment. Okay, so first thing is this: in order to design a controlled experiment, we have to identify the following things, right, of an experiment. And hopefully you've heard these words before. All right, independent variable, dependent variable. What are the controlled variables in the experiment? What are the materials needed to do this experiment? And then lastly, is there anything that you need to build for this? And that's probably something that you haven't really quite done in the past, is having to build something to design and control an experiment. All right, and that's something that we will be doing lots of throughout 8th grade science, all right, as we're going through. So let's go through each one of these things and let's talk about what they mean and so on. All right, so the first thing is this: what is an independent variable? So again, if I'm actively doing my notes, right, I am going to have a highlighter out and I'm going to highlight certain things as I'm going over it. So the first thing is, what is an independent variable? Right? And the idea of what an independent variable is it's what I, as the experimenter, is purposely changing in the experiment. All right? So there's, in an experiment, there's something that you're going to change, right? Because you want to see what happens to the experiment when I do something. And that's what the independent variable is, all right, as we're going through. A good experiment, okay? So I'm talking about a good. And what I mean by good, all right, is a valid experiment, right? A valid experiment. Because without it being a good experiment, it doesn't mean anything, all right? Your results are going to be meaningless. You can only have one independent variable at a time. And I underline at a time because you are going to be making some experiments with multiple independent variables at a time. Or the question is, can you control the experiment so you only are changing one thing at a time? Okay, and we'll get into a little bit more in the specifics about this in a little bit when we talk about multiple variables. But the idea is, can you only have one independent variable during an experiment? All right, if you have more than one and you change more than one on purpose, that means that you don't have a valid experiment anymore. Okay? So how do we identify the independent variable in an experiment? Right? If I have a good experiment question, I can name it from here. So let's say that I'm doing this experiment. It's called, how does the shape of a boat affect the amount of weight it can hold? So as the experimenter, what am I purposely changing in this experiment? Well, what I'm purposely changing is the shape of the boat. All right? I'm going to choose different shapes to see how those shapes affect the weight it can hold. So this is my independent variable in this experiment because this is what I'm changing, right? So I can choose a boat that looks like this, right? I can maybe choose a boat that's circular. I can choose maybe a boat that's a square. And I want to see which shape is going to be able to hold the most amount of weight. So as the experimenter, I am purposely changing what the boat looks like. Okay, so that's what an independent variable is. All right, so moving forward, what is a dependent variable? All right, and let me kind of clear this out. So again, I'm going to highlight this. What's the dependent variable? Right, that's one of my vocabulary words. And a dependent variable is what is being measured. Right, the key word. And this is the reason why we did presentation 1, is the idea of how to use the tools and how to accurately use the tools, because that's what 8th grade science is about. 8th grade science is about measuring things, all right, as we're going through. So the key point is what tools. So what kind of tools are you using to measure this experiment? And that's what the dependent variable is, all right, is what are you measuring? So if I have that same experiment, right, how does the shape of a boat affect the amount of weight it can hold? You have to ask yourself, what is it that I'm measuring in this experiment? Okay, and that is weight, all right, the amount of weight it can hold. So that is my dependent variable. Sorry if my handwriting is a little bit messy, okay? But this is my dependent variable that I'm dealing with. I'm measuring weight. And hopefully you're sitting there going, all right, what is it that what kind of tool am I going to be using? It's a scale, right? If I'm measuring weight, I want to use a scale to do this. But my dependent variable is the weight that my boat can hold, okay? All right, and those should be just things that you've learned in 7th and 6th grade, so hopefully I'm not going over anything brand new to you, all right? Controlled variables, okay? So this is the most important thing, because again, the idea of this entire this unit is designing a controlled experiment, right? And I can't do this enough, highlighting this part right here, all right? But what controlled variables are is what is kept the same, right, for the entire experiment, right? So these are what I would consider my controlled variables, and this is the most important variable of all the three that you have, all right? Because if we can't identify every single variable that we have to keep controlled, as an experimenter, you're gonna mess up. You're gonna forget to do something, all right? You're gonna forget that that was supposed to be controlled, and then you're gonna accidentally change it. And all of a sudden now, you're gonna have multiple independent variables, okay? So that's a key part of it, all right? And the key word that I have is invalid, because the data that you collect is gonna be invalid if you don't control your experiment. And the way you control your experiment is by identifying as many controlled variables as possible. Okay, so I'm gonna kind of put like big giant markers right here for this part, because the more you can control, the better your experiment's going to be. And the way you can do that is the brainstorming aspect of it. Is before you do the experiment, you have to really go through and say, what is it that I really need to control? So hopefully, as you guys are doing the lab this week, right, you guys have a good conversation about what is it that you need to control throughout the entire experiment. Okay, so let's go back to this experiment again. How does the shape of a boat affect the amount of weight it can hold? Okay, so the question becomes, what are the things that I need to control in this experiment? Okay, so let's brainstorm, let's go through this together. All right, so the first thing that I would think of is the material that the boat is made out of boat, right? I want to make sure, because remember, my independent variable was the shape of the boat. That is the only thing that I want to change, right? So everything else has to stay the same, or else I have completely invalid results, right? So if I'm going to make my boat out of, let's say, metal, I better make sure that I keep everything the exact same amount material, okay? Oh, that's the other thing, amount of material, right? Of course, right, if I use 500 grams to make one boat and then I use 1,000 grams on another boat, that's unfair, right? I have not controlled my experiment, all right, as I'm going through. The amount of water, right? Some people might say, does it really matter how much water I use when when I put the boat in? It could, right? So you have to ask yourself, could it, if you're asking yourself, could it affect it? That's probably something that you should automatically control. All right. Another one is the weights that you put into your boat. Right. So I'm just putting that the weights. And a rule of thumb is, I mean, I could think of probably 20 for this experiment. At this point, I want you to try and think of like at least 8 different ones. Okay. So right now we have material boat, amount of material, amount of water, the weight that I'm going to put in there, okay? The scale, right? The scale that I am using to weigh the boats, I want to make sure that I keep that the same, all right? I know this kind of goes with amount of material, but the weight of the boat, all right? Just because I make a circle boat or a square boat or a triangular boat, I want to keep that weight of the boat exactly the same, okay? So these are just some of the variables. Like I said again, I can go on, and I don't want this note to go too long, but right now we got 1, 2, 3, 4, 5, 6. Realistically, I would love for you to come up with more. I want you to think of a couple more, and if you can think of a couple more right now, I want you to put that into this notes right here. But again, the more you can think of, the better this experiment's going to be. Okay? All right. So moving forward, all right? So I have 4 different pictures for you guys. Okay? In the past, I used to have kids do a science fair experiment, right? And when they did these science fair experiments where they had to use a scientific method, I've had kids build a lot of things to do their experiment. So my question is, why is it that these students decided to build these items? So this one is a soccer ball kicking machine. So this student did an experiment where they wanted to see how does the amount of force affect how far a soccer ball will travel. This is a yo-yo dropping machine. All right. This is a hockey puck hitting machine. And this one right here is a catapult. Okay, so they were doing these experiments. All right, so the question is why is it that these people, my students, built these items? So why couldn't they just like whack a hockey puck with just a stick in themselves? Why couldn't they just drop a yo-yo themselves, right? And the big part of that is because of what we call this. And this is the biggest error of all. This is what we can't control the most. It's called human error, right? As humans, we are actually the worst when it comes to an experiment because we always mess everything up, okay? So our goal is to get rid of human error. All right. Now you're never going to be able to get rid of human error altogether. All right. But if you build something to do something that maybe a human was supposed to do, that makes the experiment a little bit better. So these kids, instead of having somebody kick a soccer ball, they built a soccer ball kicking machine. Instead of having somebody drop a yo-yo, they built this so they can control it so that way they wouldn't have human error. Okay, so the key part, so when you guys are thinking about making a controlled experiment, you have to think about having as little human involvement as possible. All right, obviously with the amount of stuff that you're going to get or supplies that you're going to be given, sometimes it's hard to build a robot. I don't expect any of you guys to build a robot for the experiment that you guys are going to be doing. Because of the time that you're going to have and stuff. But the idea is you want to get rid of human error as much as possible. And that's the reason why these kids built this. So as we're building, right, as we're doing experiments this year, this is what some of the things I want you to think about, all right, as you're going through. All right, so now let's talk about what happens when you have multiple independent variables. All right, so a lot of the experiments, a lot of the projects that we're going to be doing this year, and we're going to get to this. This is the one that we're going to be doing in a couple weeks. Which bottle rocket design will create the longest flight time? This one has going to have multiple independent variables. All right, I can't say this enough, and I'm going to highlight this. I'm going to do everything that I possibly can for you to remember it. All right, I'm going to box it. I am going to star it as many times as possible. But the idea is this. If you have multiple independent variables, you can only change one at a time. Everything else has to be controlled, has to be a controlled variable. Okay? Now what do I mean by why is what bottle rocket design create a lot of independent variables? Okay? Here's why. You're going to learn that you're going to learn that there's a lot of things that go into rocketry and what makes a bottle rocket go up in the air. And there's a lot of things that you can change about your rocket. So here's a rocket that someone maybe have made, right? What are some things that I can change? Number one, I can change the nose cone, right? I can make it rounded. I can make it pointy. I can make it longer. I can do all these things, right? What else can I change about a bottle rocket? I can change the fins, right? And not only can I change the fins, there's multiple independent variables that I can change about a fin. For example, I can change the material of the fin. I can change the size of the fin, right? I can even change the placement of the fins. For example, I can make the fins go up higher. I can make the fins go lower. All right. These are all independent variables that I can choose. Another one is the length of my overall, right, length, or I don't know if you can call it the height, length, right, of my bottle rocket. That can make a big difference in my entire experiment. So right away I have 1, 2, 3, 4. I have 5 independent variables, and I can name a few more, but I don't want to overwhelm you a little bit. But there's 5 different independent variables that come with rocket design. Design is so vague, okay? But the key point is this: I can only change one at a time. So as a group, if I decide to change my nose cone, I have to keep everything else exactly the same. Okay? Let's say as a group I want to change out the fin type. All right? Maybe I want to change, instead of using paper, I want to use plastic. Well, guess what? I can't change also the nose cone as well. I've got to keep exactly the same. The only thing that I want to change out of this is my fins. Okay? So it's really, really important that when you have multiple independent variables, you can only change one at a time. And you'll do a lab about this so that you can kind of practice before we get to the big rocketry one. Okay? All right, so last thing that we're going to get to is this. I want you to practice designing an experiment. Okay? So here is an experiment. Does the size of a wheel affect the speed of a skateboard? So what I want you to do is I want you to come up with, or ask yourself these 5 questions. What's the independent variable, dependent variable, right? What tool would you need to measure? So what's your controlled variables? And try and come up with 8. If you can come up with more, great. And then, do you need to build anything for this experiment? All right. So what I want you to do, because the answer is going to be on the next slide, I want you to pause it here. Please don't go on to the next slide because that would kind of defeat the purpose of what you need to do. Pause it here, and I want you to answer these questions right now. Okay? All right. So hopefully you paused it, you wrote some stuff down, and then you came up with these answers right here. And if you didn't, then make sure that you understand where you went wrong. So here are some of the independent variables, the dependent variable, what measuring tool. I'm not going to read this. You can see it here for yourself as you're going through it. I didn't really put this down right here. Did you need to build anything? I hope you wrote yes. And this is kind of something that I wanted to see if you did. And if you did say yes, what was it that you think you need to build? I actually had 2 things that you had to build. All right. I'm not going to go, and those 2 things specifically is how to start the skateboard, and the other one was instead of having a human ride the skateboard, I would build something that rides the skateboard. Because again, remember, I want to get rid of as much human error as possible. And starting the skateboard can cause human error if somebody pushes the skateboard. And if I'm riding a skateboard, I'm not going to ride the skateboard the same every single time. No matter how hard I try, I'm not. So if I build something to ride the skateboard, that's going to stay consistent throughout the entire time. Okay? All right, that's the notes for this week. We'll practice this in a lab as we go forward because remember, this is a big part of our unit. Okay?